Great. Hello, everyone, and welcome to a conversation about making. Making is one of the things that architects do all the time. We make buildings, we make spaces, we make places. So before I get started, though, I want to remind you that this is a live question and answer, so please type in your questions and we can talk after the presentation. I'm going to talk about three things today. First, what is making? Second, who makes? And then three, what does it really mean to be a maker? So, and what kinds of tools do makers use? So my first question, what is making? Simple answer, well, not so simple actually. It has four parts. I guess it's not that simple. But basically, to make is to cause or exist to happen. That means to create. So when we use it that way, we say, I made a design, I made plans, I made a model. The second meaning is to bring into existence by shaping, modifying, or putting together material and constructing. So in this case, it's more than just I made the design. It's actually I make a building or a lamp or a table, a park, even sometimes whole cities for architects. We make really big things. So making and making a thing, making an idea, and making a thing are different. The first one, you don't have anything physical usually, or something that's just physical that stands in for something else. So plans aren't the building; they're just the plans of the building. The second one, you actually make the thing. Finally, making is also forming or assembling groups of individuals, so making a team. And this is important in architecture because basically we make everything in a team. So we make teams all the time, and then we use those teams to make things. And then finally, you can use making in a funny way, which is to change from one form or function to another. So in other words, I can make clay into bricks, or I can make concrete from cement and stones. I can make wood into a table. So you take one thing and you turn it into something else, and that means that you're making something. So for my second big question, who makes? So if we're talking about architecture, that means architecture, engineering, and construction. Those are the three main components of our field. But then it's wide open because really almost everyone makes something. Making is just simply a part of what humans do. We like to use tools, and in fact, we even like to make tools. So once we run out of using them, we tend to make new ones to make new things. So basically, we are just about making. So then what does it mean to be a maker? And this is probably one of the harder questions, and we'll come back to this at the end of my talk, but we make environments, in the case of architecture, that everyone uses. So architects make the things that make the world around you. If you think about it this way, a city is made up of houses, office buildings, parks, places for you to watch a movie, places for you to talk to your friends, places for you to skateboard, a place for you to read. Those places were probably made by an architect. So architects tend to shape the world around you. And in that way, we also tend to, in some ways, contribute to the way you think about the world around you. So let me be a little specific, because my next part is really to talk about the kinds of tools that we use. And at this point, the images that have been playing behind me, I'm going to start trying to talk to some of those images, but you're going to see a whole sequence of tools and ways that tools are used in architecture. And I'm going to talk about it in really sort of two or three ways, two basic ways. One is to talk about tools as additive or subtractive, meaning they're digital or they're analog, and I can explain the difference between those. Or I'm going to talk about it in terms of them being real or virtual. Real meaning that it's something that you work with in the world that's solid, that you can feel, taste, touch, and smell. Virtual, actually, the virtual world's getting more complicated every day. It used to be that I could safely say you might not be able to smell, taste, touch, or feel it, but we're slowly moving towards that horizon, and in the future, that might be something that we could talk about. Right now, it's probably true that if it's virtual, it's something that appears to you in the world or changes the way the world appears around you. But when you go to actually engage it with one of your senses, it doesn't hold much smoke yet. Or it's like smoke. It doesn't hold. It's not too solid. So for the first, let me talk about the kinds of tools we use. But before I start that, let me make a quick distinction between the digital and the analog, because you're going to hear a lot of people talk about digital tools, and it's sometimes unclear what that really means. Some people think that that means that it's just the computer. And the real question is, yes, it is the computer often when we talk about digital tools, but what does digital really mean? There's a quick and easy explanation for this. So if you look at a watch, you can have two kinds of watches. So picture two kinds of watches. One will have an LED readout, and you can see the numbers going. So it says 1205, 1206, 1207, so on and so forth. And you only see that as 12 colon, oh 05, 12 colon oh 06. That's a digital world. That means that you're seeing things sequentially. So one right after the other. And you can only see that set of numbers. Now, if you think about it for a second, the only reason you know that that 12 colon oh 05 is a watch is because I've just told you it's on a watch and you see it on a watch and you get that. But that actually could be something else. That could be another app could be used in another way. That 12 colon oh 05 could be applied in another domain, not just necessarily to time. So it's not as specific in that sense. It's just the numbers and the sequence of numbers. The other kind of watch that you can see is an analog watch, meaning that you can see all of the hours in the day or in the 12 hours in the day all together. So you see the 12 at the top, the 6 at the bottom, and you can actually, you're never sure if it's exactly 12:05 or if it's 12:05 in a couple of seconds because the clock, the watch face that you're looking at is analog, meaning that it's showing you things more continuously. And that's one of the basic differences that becomes important when we start talking about the tools that we use, because how we control the tools and what the tools allow us to do in terms of digital and analog makes a difference. So the first set of tools that we tend to use are the additive ones, meaning that you're adding some kind of material, not taking it away. So very simply, pencil and paper is an additive tool. You have the paper, you make marks with a pencil, et voila. You get a picture, you've added the picture to the paper. But the same kinds of things also apply to computing when you're working with a drawing in a computer, in that when you print it and you plot it, which is what architects do, we like to plot things. When you plot it, it means that the computer is telling a machine, a plotter, or a printer how to make a mark on a paper. But it's adding in that process in either way. More exciting, and if you look behind me, we might be able to look at some of these, are 3D printers. That's where you're actually thermally fusing plastic filaments. You're often using ultraviolet light to cross polymer resins, or you're depositing an adhesive droplet and you're binding it with some kind of powder. You might even be cutting and laminating sheets of paper, or you might be using a laser beam to fuse metal particles. But in either way, what you're doing is the machine is layer by layer by layer, adding material and building up a model that represents what you're thinking about. These are used by architects for rapid prototyping, digital fabrication, so on and so forth, because they're computer controlled. That's the digital part of the tool. The material, the plastic stuff that you're using, the different sheets of paper, the laser beam that's actually adding metal particles, that material is analog. So that's still something that you can see seamlessly all together. Basically, you're not being given just a little bit of information at a time. Or in our case, we might also call it just simply physical. So digital materials themselves, in other words, where the material would be digital, is still a bit in the future, but they're coming sooner than you may think. And there may be some point when you can actually 3D print a radio. All the copper, all the wires that are not copper, all the rubber, all the plastic. But we're not quite there yet. Right now, what we can do is print things that look like a radio, but they still don't work like a radio. So computer-controlled tools are one of the most important things to happen in making, and you'll see a lot of images behind me that are showing computer-controlled tools in operation. They allow us more precise control, faster production, and in some cases scalability, meaning I can change the size of the thing pretty easy. Then we've got subtractive tools. And these are kind of interesting because it means they're taking material away. So typically we work with things like table saws, routers, and drills. A lot of these tools we're making models. So the main things that architects make are either models and drawings, and we're looking at tools that do both of those. So the computer or computerized numerical control, they're called CNC machines, cut or modify physical materials. It's like taking a drill, a saw, and a router, rolling it all into one machine, and then attaching a computer to it so you can tell the computer what to tell the machine to do. You can even add a plasma cutter, that's pretty exciting, or a torch, so that you can add things together and then bind them. They let you do a lot of coordinated operations like cutting, shaping, carving, and reaming in the process of making something. Architects, we use them a lot to model environments, buildings, and objects. So furniture, lamps, things for your house, all sorts of stuff. We always like again, we like making things. The other one that we like to use is a laser cutter. Now, laser cutter is a little different. It's also a computer-controlled machine, and it's also subtractive in that you're taking material away, uh, you know, uh, and so you're either burning, melting, or blowing it away in some way using a jet of gas. So that machine, though, you also have to, it's very precise, allows you to make very precise cuts and marks, so you have to use a computer with that too. So that's kind of the tools that we use that involve something that's very obviously physical, some kind of material. You either subtract material, you add material, and sometimes, as in the case of the CNC machine and the plasma cutter, you can actually fuse two different materials together. But the other component of this, which is my second topic in terms of the tools, is whether or not they're real or virtual. So we make drawings and models that are virtual and real and sometimes actually mixed. That's called MR or mixed reality. So on the real side, pens, pencils, paper, crayons, colors, all sorts of things. Those can typically we think of those as real. My hand is moving it on the paper and I'm making a mark and it's in the real world so I can see it really directly and I can reach out and touch it. But sometimes it can also be thought of as mixed reality because I might make a drawing, let's say a digital drawing on a smart board, so I'm making a mark that's already a digital mark, and that goes to a plotter, and that actually has to be computer controlled. But then the final product is actually a piece of paper. So it works this way. My brain, which is also, a very powerful tool, thinks of the idea, say about a house, and it goes from my brain, which is physical, to the computer, which is digital, to the plotter, which is digital and physical, and then we finally get a drawing that's physical. But in addition to those tools, we also use the computer just on its own. So we'll also make a lot of things that are just in the digital world to start with, or that we might plot, in other words, print, make physical, make marks on that, and then go back into the digital world and work on it again. And you can see some of that happening behind me too in the videos. So that we call computing and computer-aided design, or CAD. We use these systems to help create, modify, analyze, or optimize a design. It can be done two-dimensionally and three-dimensionally. We call this either computer-aided design, or you'll also hear people say computer-aided drafting. But the last one I want to talk to you about is the augmented reality or the mixed reality, when you're actually making a hybrid of the virtual and the real. And this is something that's emerging And something that you're going to see behind me too in a minute when you were looking at some caves and some goggles that actually allow you as the designer, the maker, to picture what it is that you're trying to make even before we do it in a model form. So one way we think about this is we use what's called augmented reality, which is a live, direct, or indirect view of a physical, real-world environment whose elements are augmented, that is supplemented by computer-generated sensory input. That can be sound, video, graphics, GPS data, you name it. And one of the best examples of these is something like the Oculus Rift. So it's a set of goggles that you put on, a kind of headgear. It projects a 3D digital image that you can see, and it actually is pretty convincing. Your body thinks you're actually walking through that space. You can reach out. You can't touch anything, but your brain says, hey, there's something out there. So a lot of times you find yourself really inhabiting the space, really inhabiting the world that you're imagining. And finally, there's an even bigger version of that, one that you can kind of crawl into. It's a lot like the holodeck on Star Trek. This is the one I was waiting for always. I'm pretty excited that we're just about here. And that's a room-sized cube. They can also be hexagons, ovals, various shapes. But you actually walk into this. You can use a joystick, and you can visit someplace like Egypt or the moon. You can move around in that space, and you can actually reach out, touch things, and sometimes make them move too. So this is a fantastic way to make an image of a place that you're imagining and then take other people there too. Okay, so what does this making stuff really mean in the end? What does this culture of making really let you do? Well, I think other disciplines can answer that a lot of ways, but for architects, it means that the kinds of spaces you design support the kinds of things people can do and actually the kinds of thoughts they can have in their space. This is a little bit more obvious if you imagine for a moment trying to play soccer in an office building. The field is made for soccer, so you can play soccer in a soccer field, no problem. But the same way, just an office building is made for the things people do in offices. It has desks and chairs and places for your books and places for your pens and pencils. You can have a soccer game in an office building. That's true. People have done all sorts of things. But you'll really have to think differently about the way you play the game. In other words, you'll have to come up with a sort of office version of soccer or a soccer office version field of some kind. This still means, so in either way, that the architecture, that is the building, the space, the environment, the field, is shaping your thinking. In the case of the soccer field, it means that you had to think about a new game. Couldn't just be soccer. It had to be a soccer office game that you were playing in the building if you decided you want to play it inside instead of outside. So for architects, making is a kind of thinking. They're really interchangeable in some ways. It's a way of thinking that shapes how we all think about the world, in fact. So our making does really shape other people's thoughts too. This talk tried to engage the different ways that architecture thinks and makes the world, tried to show you the kinds of tools that we use, and tried to show you a little bit about some of the future, some of the tools that we're just about to use broadly in the architecture field that will change even more the way we think and make. So I'd be happy now to take questions and hope to talk to you about making. Thank you. All right. So I think we're live now for the Q&A, and I've already got a few questions, so I'm just going to jump right in. The first question I have is, someone asked me, said, the cube is really interesting. What would be a real-life application of this cube? So there are a couple of answers to that question. The cube can be used by architects to design spaces. So one of the ways we use it is to look at interior spaces and to think about where a wall might be, where a piece of furniture might be, how high a space might be, to really look at a design that you've done. But we can also look at them in terms of the city. So we might look at a neighborhood and actually design, 60 houses that make up a block in a neighborhood and then rearrange those and think about what the streetscape looks like and how many trees and, is that the right kind of piece of furniture on the front, in the front of the house, and is the lawn correct. So we might also design the city. There are a couple of other things that we use them for, and that is doing very complicated projects where you have a lot of services that you have to manage. So a lot of pipes and things that you have to do in the ceiling. So we also do things where we might build that data and then look at it in the cave. The other thing is sometimes it's great just to go and look at big pieces of architecture that you might not get to visit. To actually go into the cave environment and just go see what those might look like. Or we all can tell that NASA is basically going to take us to Mars, the next big step. And architects are working on the design of the space capsule and working with the Mars astronauts to try and figure out what would be the best environment. So you can use the cave for that too. So I have another question, and I'm going to go ahead and just keep going. What is your most interesting project? What technology did you use? What are some interesting projects going on at the university? So there are a couple things here. Uh, so I work in an area called neuroscience and architecture, and we've used a lot of this technology to design, to look at spaces that people occupy who have actually a different perception of space. So that's what I've used that for. But I think that the most interesting projects I've worked on were the really big projects that I worked on overseas. I had a blast doing that. Lot of big teams of architects, and we really enjoyed that. So another question I've got here is, when do you think the RV will become more common in the architecture office? Actually, it's starting now, believe it or not. A lot of architecture offices are beginning to use uh, at least augmented reality environments, if not mixed reality environments yet. Some offices are already using the cave. They don't have one, but they'll go to a local cave, usually the university, and they'll walk their clients through environments that way. My prediction is that just like the computer was a new piece of equipment in the 1980s and 90s in offices, the cave is going to be the next piece of equipment in the 2020s. So I'm happy to take more questions. Just jump in and and give me a chat, give me a buzz, and I'll be happy to fill you in. So I've got another question asking me to talk a little bit about the neuroscience and architecture link. Well, this is kind of a new area in architecture that's emerging because we're able now with neuroscience to understand a little bit better how people are perceiving space. So I can actually look a little bit into your brain and imagine or project based on some of your responses to some stimuli how it is that you might be perceiving the space around you. What that's enabling us to do is to make architecture that's more responsive to the way that you're seeing space. So let me put it this way. If you have difficulty, let's say, perceiving depth, in other words, you don't see depth perception very well, I might be able to make a space that responds to you in a more direct way, that helps you navigate through that room or series of rooms because it's set up to help enhance what may be missing in your depth perception. Another way to think about it is this. So let's just say that you don't have a very good memory. You can't remember how to make an omelet, but you really want an omelet. So you're standing in your kitchen and you're trying to remember what the ingredients are. You might just say something like, want to make omelet, and your refrigerator and your kitchen, your cabinets, the things around you, believe it or not, we can make them now so that they might actually start responding to you. So your refrigerator might actually say, you know, talking to you, these are the ingredients that you'll need, so on and so forth. So we're doing it in two ways in neuroscience and architecture. We're making architecture that's smart, smart rooms, smart walls, and then we're also making architecture that starts to operate a little bit more like your brain. So there are different ways in which it's coming about. It's pretty exciting, I think. It's a new field, and it definitely overlays with the technologies. Because the great thing about the technology is when you combine it with the neuroscience and architecture, I can make things that move. I can make environments using virtual environments that will help you navigate the real environment. If you're really interested in this, you might go take a look at a project called ADA, A-D-A. This is a smart space that was made for the Swiss Pavilion in 2000. And ADA was a programmed room. She would try and keep people in the space by playing with them. She used lights, music, and all sorts of things. But if you're interested in that, you can just Google it. ADA is pretty great, and you'll certainly get some sense of how an environment can actually respond to the way that someone might see it. All right, so come on, let's do some more so that we can talk a bit more about some of the things that architects do with the technology that they have. There are all sorts of ways in which it's used in the office. Most of them probably unfamiliar to you if you haven't worked in an office, but things like smart boards, um, boards that'll capture drawings. You can actually even draw in space in 3D now. If you go on the web, you can see that too. Just Google draw in space 3D, and you'll find stuff that you can see that way. Okay, great. So I'm going to go ahead and close the session down now. Thank you so much. I'm going to sign off. Talk to you soon. Bye.